What's up, everyone? Welcome back. Patrick here. Moving on to the next example on the exponential functions unit test for grade 11 functions. In this example, we are given an exponential function and we're going to have to graph it. We're going to have to go through the entire process using transformations, and then along the way, we're also going to have to state some of the characteristics. Now, as usual, what I recommend, pause the video now, try to graph this yourself. Try to write out all the characteristics, the domain, range, etc., and then compare your answer to mine. We've done tons of graphing examples in the lecture videos, so I'm assuming by now you're feeling fairly comfortable with the process. And if you're not, you may have to go back to the lecture videos, go through those again, and then come back and try this question yourself. So we are given f of x equals 0.6 in brackets 3 to the power 2x minus 6 minus 2. So just in general, what is the general transformation format of an exponential function where there's going to be some kind of base, right? And then we're going to have k bracket x minus d plus c. Now remember, with exponential functions, the parent function, it actually always changes. It's not always constant like the functions we've dealt with before, like the absolute value or the square root function or 1 over x. The parent changes depending on what this base is, right? So in this case, what's the base? Well, it's 3. So our parent function is going to be f of x. Let's, so we're not confusing the f of x here. Let's just write y equals 3 to the power of x, right? That's going to be our parent function right there. And then in part A, they're also asking us what are the transformations that are applied. And so what we want to do is we want to get our A value, our K value, our D value, and then our C value. Well, notice the A value, super easy to get, right? This A value, it's just going to be 0.6. The K value and the D value, you got to be careful. Remember, what has to happen? The k value has to be factored out, and notice that here it's not factored out from the x. So we actually have to rewrite this function as 0.6, 3 to the power of 2 bracket x minus 3. And now this function is in that general transformation format. And now it's super easy to match up the k value and then the d value. So notice the k value is 2. Right? K value, so the k value is 2 in this case. What is the d value going to be? Well, the d value is going to be 3, right? It's x minus the d value, x minus 3. It's always going to be the opposite sign of whatever that is. So the d value is going to be positive 3. And then finally, we have our c value at the end, which is the minus 2. So that's our c value like that. So sometimes you're going to have to take an exponential function and rearrange it in a way where you got to get it in that general transformation format. Sometimes it'll be given to you from the get-go. Sometimes you're going to have to do a little bit of algebraic manipulation. And if you went through some of the graphing videos in the lecture videos and the chapter videos, you can see that sometimes you have to do a lot of algebraic manipulation to get it in this format. Sometimes these functions can be given in weird formats initially. All right, so we have our transformation values, and now we can go through each of them one by one and then state what the transformations are. So notice that this A value of 0.6, what does that mean? Well, there is a vertical, you know what, I'm going to just write it in short form, vertical compression by a factor of 0.6, right? Because the A value is between 0 and 1. And whenever the absolute value of A is between 0 and 1, it's going to be a vertical compression. Now the k value of 2, what does that mean? Well, that's going to be a horizontal compression by 1 over 2. Remember, the k value you always flip when you are describing the transformation from the k value. Notice the a value, the k value, they're not negative. Neither of them are negative, so there's no reflections in either of the axes in this particular question. Then the d value of 3, that means that there's a vertical or a horizontal translation right 2 units. And then a c value of negative 2, that means there's a vertical translation down 2 units. And that's pretty much it for part A, those are the transformations that are going to be applied to this parent function y equals 3 to the power of x. Yo, what's up? Quick little intermission here. Wanted to mention a few things quickly and we'll get right back into the question. First off, if you are getting value from this video, if you can please like the video and subscribe to my channel, it does help me out a lot. Number two, if you're watching this on YouTube, you can go to the description box and there is a link that will take you to my website, allthingsmathematics.com, where all my courses are organized so you can watch the videos in order, and I'd recommend doing so because lots of concepts carry over from one video to the next. Also, for lots of the courses, at the end of the chapters, you can find tests that you can practice with, and the tests have video solutions as well. Number three, if you feel like you need personalized help and tutoring, give me a shout. I currently tutor students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. You can text me. We can discuss availability and then we can book a session. My contact details are on my website. And lastly, feel free to forward the website to any of your friends who are also taking the course, who you feel can benefit from these videos as well. Hit me up on all my socials. It's All Things Mathematics for all of them. Back to the video we go. Now in part B, what they're asking us for is a couple of characteristics for this function: the domain, the range, the y-intercept, and then the asymptote. And usually I like to make the graph first and then get the characteristics. But notice in this case, they're asking us to graph it after in part C. And some questions you might get them asking you for these characteristics without making a graph. So you have to know how to get these without having the luxury of looking at a graph as well. Now, the domain for an exponential function, for any exponential function, is always XCR. Unless you're maybe dealing with like a word problem and then the domain's going to be limited, like time has to be greater than or equal to 0. But if you're just looking at an abstract exponential function, there's never any limits on the domain. It's always XCR. Now the range is a little bit more intricate. There's a little bit more detail there, and I'm going to leave that for last just because it's actually going to depend on the asymptote, so I want to get that first. The y-intercept, what you would do is you would plug in 0 for the x value here. And so what would happen is you'd end up with 0.6, then you'd have 3 to the power of -6, right? 0 minus 3 is -3 times 2 is -6, and you're going to have a -2. So you got to do this exponent first, multiply by 0.6, -2. And what would happen is you would get approximately, as a decimal, -1.99. I think there's like 3 nines, right? It's actually going to be very close to -2, which is going to be the horizontal asymptote. So make sure you don't put an actual -2 there, okay, because that's actually not going to be in the range of this function. And you could also get, if you wanted to, like a fraction. Okay, I just got the decimal. It's going to be approximately that if you plug all of that into your calculator. Now, the asymptote, remember, an exponential function always contains a horizontal asymptote, and it's always going to be the c value. Right? The horizontal asymptote is always going to be the c value. Same as, like, remember the parent function 1 over x? 1 over x always has a vertical asymptote, and it's the d value, and then it also has a horizontal asymptote. It's always the c value. Well, an exponential function only has a horizontal asymptote, and same thing. It's based on always the c value. So the equation of the asymptote in this case is y equals -2. Now, the range, it depends on two things. I've mentioned this in the lecture videos before. What does the range of an exponential function always depend on? It depends on the horizontal asymptote, and it depends on the sign of the a value. Those are the only two things that the range depends on, because the range for an exponential function is always going to be YER such that y is either going to be greater than the horizontal asymptote, which is -2 in this case, or it's going to be less than the horizontal asymptote, right, which is -2 in this case. And whether it's greater than or less than is going to depend on the a value, whether it's been reflected or not. If the a value is positive, then it's always going to be y is greater than the horizontal asymptote. If the a value is going to be negative, it's always going to be y is less than the horizontal asymptote, right? So in this case, the a value is positive, Okay, the horizontal asymptote is -2, so we know our range is going to be y is greater than -2. Basically, what's going to happen is like this function is going to have a horizontal asymptote at -2, and it's basically going to be above that horizontal asymptote. If the a value is negative, it would be below that horizontal asymptote, right? So then it'd be y is less than -2. So you could play around with these different kinds of transformations and Desmos, and you'll always notice the range always depends on the sign of the a value and then whatever the horizontal asymptote is. It doesn't depend on the sign of the k value. Okay? It doesn't depend on whether it's been reflected or not in the y-axis, because let's say that the k value is negative, well, the function would still be above that horizontal asymptote of -2, it would just be going downwards, right? But the range would still be y is greater than -2. So it doesn't depend on the sign of the k value, it depends only on the sign of the a value. So that's how you can know from just looking at an equation of an exponential function what the range is going to be without necessarily having to graph it. And now in part C, let's finally go through the graphing process. So we want to start with our parent function, which is 3 to the power of x. So the x values that I usually use just 3 x values, but if you want to use more, you can. If you want to make it a little bit more detailed, I'm going to use 3 in this particular example. So 3 to the power of -1, it's like 1/3, which is like, let's keep this in decimals, 0.33. 3 to the power of 0 is 1, 3 to the power 1 is 3, like that. So that's our parent function. Again, depending on the base, you're going to have to create this table, right? It's not like a standard, for example, as I mentioned before, like an absolute value of x table, where you just got the x values from -2 to +2, and then you got your standard y values, right? You're going to have to actually make this with exponential functions, because the parent function is changing depending on what the base is. Okay, and then what we're going to do is we're basically going to transform those values. Now remember, if you have a parent function that has the points x and y, how do we transform those points? Well, we take the x values divided by the k value and add d, and then the y values we multiply by the a values and then add c, like that, right? So in this case, what we're doing is we're taking the x values, dividing it by 2, and then adding the d value of 3. So let's write that, x over 2 plus 3, and then the y values multiplying by the a value, subtracting 2, like that. And so basically what we have to do, let's kind of color coordinate this, we have to take these x values from the parent table and put it through this formula over here. So -1/2 plus 3, that's going to give us what? 2.5? 0/2 plus 3, that's going to give us 3. And then 1/2 plus 3, that's going to give us what? 3.5. Like that. And then doing the same thing with the y values, taking these y values, putting it through this formula, you'd end up with these corresponding y values right here. Okay, so we got our table, and so let's make this graph now. Now I'm going to be doing this just here on the board. It's not going to be necessarily to scale, but you can graph it on graph paper on your end, make it a little bit more precise than what I'm going to do. But first thing I always like to start with is the horizontal asymptote, right? Because then it allows me to kind of see how I could organize these points and the shape of it, and it can't go below that horizontal asymptote either, right? So I'm going to start with the horizontal asymptote of -2. Now, if I was to graph these points, we would have what? Let's say 2.5 is like here, so that's like -1.8, and then we'd have 3. -1.4 is above -1.8, and then we'd have 3.5. Just going to be at like something like that, -0.2. Again, not the most scale. We also have remember, the y-intercept, right, which was like -1.99, which was like very close to -2, even though that's not a point here on the table that we got after using transformations. We did get that point earlier. So if you want, you might as well use that as well, put a little bit more detail into your graph. And so this graph is basically going to look what? Something like, and it starts increasing here. Kind of goes like this. So something like that, right? So again, if you do this on graph paper, you'll have a little bit more detail, but nevertheless, this is pretty much the shape of the graph. This is how it would look. If you took this, graphed it in Desmos, this is how the graph would look. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.